Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if computers can really understand how we speak, just like we do? Could a smart AI tell us if someone has an accent in English, perhaps even better than a person might? Today, we're diving into a fascinating study that puts some of the most advanced AI models to the test, comparing how they judge foreign accented English spoken by Brazilians against how real people do it. It's an exploration into whether artificial intelligence can truly grasp the subtle and sometimes messy world of human language perception. So, the big question here is whether these powerful AI language models like Google Gemini can actually judge English spoken by people who learned it as a second language, specifically Brazilians, in the same way humans do. The researchers wanted to see if the AI's accent ratings would match up with ratings given by actual human listeners. Here is how they approached it. They took recordings of Brazilians speaking English over the phone. These recordings were already rated by 3 native English speakers using a simple scale. 1 meant no real accent, 2 was a mild accent, 3 was a noticeable or moderate accent, and 4 was a strong accent that might even make it a bit hard to understand. The researchers then used 2 versions of Google Gemini, a free one called Gemini Flash and a paid one called Gemini Pro, and asked them to rate the same audio clips using that same 4-point scale. And what did they find? Well, it turns out computers and humans don't always see eye to eye, or in this case, ear to ear. The study found that the AI systems, especially the paid Gemini Pro version, tended to rate the accents as stronger than the human listeners did. Imagine a coffee that a human judge calls medium roast, but the AI says extra dark roast. The AI often gave higher ratings, meaning it perceived a stronger accent, even when humans thought it was just moderate. The researchers believe this difference comes down to how they judge. Humans, when listening to someone speak, don't just hear sounds. We subconsciously take in all sorts of things like the speaker's background, how we feel about certain accents, and even just our personal tolerance for variations. It's a mix of sound, social cues, and experience. But the AI, it seems, is focusing more on the pure acoustic differences. The actual sound deviations from what it knows as standard English, it's like the AI is a super precise sound analyst, but it is missing the social context that humans naturally use. Think about it this way. Accent perception for us isn't just about recognizing sounds. It is something we learn through living and interacting. We hear accents all around us, and over time, our brains learn to accept certain variations as normal, especially if they come from people we interact with regularly. Even though AI is getting incredibly smart, it still has trouble with the sheer variety of human speech. Accents are a big part of that variability. Most AI models are trained on huge amounts of data, but often that data is heavily skewed towards native speakers, which can make it harder for them to understand or judge non-native accents fairly. This kind of research is really important because we're using AI more and more. We need to make sure it's fair and doesn't end up making biases worse. If AI can't judge accents like humans do, it could cause problems in things like language learning tools or even automated job interviews. So, let's get into the nitty-gritty of how they did the experiment. They used recordings from a special collection called the CSLU corpus. These are real phone conversations where Brazilians are speaking English. They picked out recordings where the original human raters all agreed on the accent level. This made sure they were starting with a strong, clear baseline. Then, to keep things fair and controllable, they adjusted the volume of all the recordings so that things like loudness wouldn't unfairly influence how the accent was judged. They brought in 3 new native English speakers to rate the recordings. These listeners weren't necessarily linguistic experts, but they were trained to use the scale consistently, kind of like a typical listener might. Then came the AI. They gave the same 36 audio clips to both Gemini Flash and Gemini Pro. They kept the instructions super simple, just asking the AI to rate the accent on the same 4-point scale, making sure it focused on accent and not how easy it was to understand the person. Let's look at Gemini Flash first. The free version, it tended to give higher ratings. For example, a significant chunk of its ratings were for a noticeable accent. What is really interesting is that Gemini Flash also gave strong accent ratings, which the original human raters actually excluded from this part of the study. This shows the free AI was already leaning towards overestimating the accent strength. Now, Gemini Pro, the paid version, this one was even more aggressive. While it did assign a good number of mild and noticeable ratings, similar to humans, it almost completely ignored the no or negligible accent category. This suggests it found it really hard to say someone had almost no accent at all. And here is the kicker. Gemini Pro gave the highest percentage, a whopping 27.8%, to the strong accent category. Remember, 0 humans in this study rated any of these selected clips as a strong accent. This clearly shows Gemini Pro has a strong bias towards rating accents as more severe. To really dig into these differences, the researchers used a fancy statistical tool called a cumulative link mix model. Think of this as a way to not just look at the numbers, but to understand the underlying patterns and how likely these differences are to be real and not just by chance. This analysis confirmed that both AI raters had a systematic tendency to give harsher accent ratings than the human listeners. Gemini Pro showed the biggest bias. The numbers here, like the p-value being less than 0.001, tell us that this result is highly unlikely to be due to random luck. It's a real significant difference. The odds ratio helps us understand the strength of this bias. For Gemini Pro, it is 8.25. This means the paid AI is over 8 times more likely to give a higher accent rating compared to the humans. That is a huge difference. Gemini Flash also showed a significant bias towards higher ratings, though it was less extreme than Pro. Its odds ratio was 2.76, meaning it was about 2.76 times more likely to give a higher rating than humans. They also looked at how much the raters agreed with each other. They used a measure called Cohen's kappa, which tells us if raters are agreeing more than they would by random chance. The agreement between humans and Gemini Flash was slight, and between humans and Gemini Pro, it was only fair. And get this, the agreement between the two AI models themselves was practically negligible. This means the human ratings were not reliably reproduced by either AI, and the two AIs couldn't even agree with each other consistently. Let's look at the confusion matrices. These tables show us item by item where the disagreements happened. In the matrix comparing humans and Gemini Pro, you can see that when humans rated an accent as negligible or mild, Gemini Pro often shifted it up to noticeable or even strong. When humans said noticeable, Pro frequently called it strong. It's a clear pattern of uprating by Gemini Pro. The matrix for humans versus Gemini Flash shows a bit more overlap. Flash agreed with humans more often, but it still showed a tendency to rate accents a bit higher, pushing some negligible or mild ratings up. The deviations here were less extreme than with Pro. And when we compare the two AIs, we see that Gemini Pro is consistently more severe than Gemini Flash. Flash often downgraded Pro's strong ratings to noticeable or mild. So even within the same AI family, there are significant differences in how they judge accents. Overall, when you look at all three groups together, the agreement was very slight, barely more than what you'd expect by pure chance. This really hammers home the point that humans and these AI systems are working with different criteria. So, what is the main takeaway here? The study found that current LLMs like Gemini Flash and Pro don't really mirror human judgments of accentedness. They can give ratings, and numerically Pro's ratings for mild and noticeable sometimes match the human percentages for those categories. But this similarity was superficial. The big picture is that AI systems showed significant differences from how people perceive accents. The low agreement scores, especially between the two AIs themselves, are quite concerning. It means that even advanced AI can't reliably agree on how to judge accents, let alone do it the way a human would. The fact that both AIs rated some clips as strong accent when the original human raters didn't is a really important observation. It highlights that the AI models can easily overestimate accent strength. Gemini Pro's consistent harshness suggests it has a fundamentally different idea of what a strong accent is. Gemini Flash, on the other hand, seemed a bit more all over the place, suggesting its internal criteria might be less stable. So, while AI can give an answer that might look similar on the surface, it is not capturing the actual human experience of judging an accent. Humans rely on our life experiences, our understanding of social norms, and our expectations. We filter out acoustic variations based on context. AI, on the other hand, seems to be treating it more like a simple measurement of sound deviation. If a sound deviates, it gets a higher score, sometimes without considering the social context or learned tolerance. It is like the AIs are measuring deviation, while humans are measuring how well something fits into a social context or our past experiences. This means AI models might be interpreting categories literally or based on probabilities, not perceptually in the way humans do. This research is super important for anyone using AI for language tasks. It shows we can't just blindly trust AI accent ratings. While these models are powerful, they lack the deep understanding of social context and learned perception that humans have. They might be useful for initial screening or identifying specific sound features, but they aren't yet reliable judges of accent quality in the way humans are. Interestingly, the more advanced paid model Gemini Pro was actually less like human perception than the free Gemini Flash model. This is a really key finding. It means just because an AI is bigger or more complex doesn't automatically make it better at tasks that require nuanced human understanding, like judging accents. In the end, judging accents is a complex human skill. It involves more than just processing sound. It's about culture, experience, and social understanding. And right now, even the most advanced AI models can't quite capture that. They might be able to hear the difference in sounds, but they don't understand the social meaning behind them. So, what's next for AI in this area? Maybe instead of trying to perfectly mimic human accent judgment, future research could focus on whether AI can accurately predict something like intelligibility, which is a more practical measure of how well someone can be understood. Or perhaps AI models could be specifically trained on human perceptual data to better understand those social and contextual nuances. For now, we need to be cautious. In settings like language tests or scoring pronunciation, AI ratings shouldn't be used as a direct replacement for human judgment. They just operate on different principles. Human listeners, with our lived experiences and social understanding, have a more flexible and nuanced way of interpreting accent. We understand that deviations often don't hinder communication and are part of a speaker's identity. So while AI is amazing at many things, when it comes to the subtle art of accent perception, humans are still leading the way. AI can be a helpful tool, but it hasn't yet mastered the complex, social, and personal dance of understanding how we speak. Don't forget to like this video if you found it interesting, subscribe for more science deep dives. And let me know in the comments what AI topics you'd like us to explore next. See you in the next one.